This is section 2.2, inductive and deductive reasoning. So inductive reasoning is where we use a pattern in specific cases to write a conjecture for the general case. And a conjecture is just some unproven statement based on observations. So what is the next figure in the pattern? Alright, so it looks like when we look at it, we have 2 pieces, then 4, then 6. So I can make a conjecture that the next one is going to have 8. So I'm going to poorly draw my 8 pieces, and then I'm just going to shade one of them. Alright, make a conjecture about the sum of any 3 consecutive integers. So let's try some examples. 3 consecutive integers. So that's like 1 plus 2 plus 3, which is 6. What if we try 5 plus 6 plus 7? 5 plus 6 is 11. Plus 7 is 18. What about 10 plus 11 plus 12? 10 plus 11 is 21, plus 12 is 33. So let's try to make a conjecture about these. So I notice that the middle number times 3 always gives us the answer. 2 times 3 is 6, 6 times 3 is 18, 11 times 3 is 33. So my conjecture is that the sum of any 3 consecutive integers is the same as taking the middle number times 3. So I use those examples to try to make my own rule about it. You can try more if you don't believe me, but that's the conjecture that I probably should make. So proving conjectures. Proving that a conjecture is always true is hard. It's really hard to prove that something is always, always, always true. The easy thing is disproving. All you have to do is find one example that doesn't work, and then you just proved it false. So let's find a counterexample to show that each conjecture is false. So the value of x squared is always greater than the value of x. So I'm just going to try different numbers, see if it works. So let's say x is equal to 3. 3 squared is 9, and 9 is greater than 3. Okay, so that one didn't work. What about negative 3? Well, that's still 9, and it's still greater, so that one didn't work. So we tried positives, we tried negatives. Let's try fractions. 1/2 squared, 1/2 times 1/2 is 1/4. Well, 1/2 is greater than 1/4, so that one contradicts, or it's a counterexample. So there we go, found one. So try different kinds of numbers, and you should be able to figure out one of them doesn't work. So the sum of 2 numbers is always greater than their difference. All right, so let's try numbers. What about 2 plus 3 is 5. 2 minus 3 is negative 1. Well, the sum is greater, so that one didn't work. Let's try negative 2 plus negative 3. That's negative 5. Negative 2 minus negative 3. Subtracting a negative is adding a positive. That becomes 1. And look, we found an example where the sum is not greater than the difference. So we talked about inductive reasoning. Now let's talk about deductive reasoning. So while inductive reasoning is patterns and kind of a little bit of guesswork, deductive reasoning uses facts, definitions, accepted properties, and laws of logic for a logical argument. So we have two things of deductive reasoning. So we have the law of detachment. If the hypothesis of a true conditional statement, so if your if-then statement is true, if your if part is true, then your then part also has to be true. That's the law of detachment. The law of syllogism says that if P implies Q and Q implies R, then P implies R. So what we see here is we see that these two are the same. So then we can skip straight from P to R. So if two segments have the same length, then they are congruent. Okay, that's a true if-then statement. You know that BC equals XY. Using the law of detachment, what statement can you make? Well, we know that these two segments are equal, meaning they have the same length. So using the law of detachment, looking over here, our conclusion is then they are congruent. So we can say that BC is congruent to XY. And then use the law of syllogism to write a new conditional statement that follows this pair of true statements. So if a polygon is regular, then all angles in the interior of the polygon are congruent. If the polygon is regular, then all its sides are congruent. So we know if it's regular, then all angles of the interior are congruent, and if it's regular, then all sides are congruent. So if, we can conclude if the angles in the interior are congruent, then all its sides are congruent. So we're taking pieces from two different statements and we're kind of piecing them together. So remember, bottom line, inductive is using patterns and deductive is using rules.